Peanut butter may look like a simple creamy spread when it lands on a grocery shelf, but behind every jar lies a massive industrial process built around roasting tunnels the size of buses, pneumatic shelling systems, high-speed grinders capable of turning peanuts into liquid in seconds, and automated filling lines that can fill thousands of jars per hour. What starts as a raw, dusty peanut fresh from the field becomes a smooth, pasteurized, consistent food product that must meet strict standards for flavor, texture, and microbiological safety. And today on the How Factory, we're going deep inside the factories where peanuts are cleaned, shelled, roasted, blanched, ground, emulsified, stabilized, filled, capped, and shipped by the ton to supermarket shelves worldwide. What looks like a simple sandwich ingredient is actually the end result of a carefully engineered combination of food science, heat treatment, mechanical grinding, and ultra-precise packaging. The process begins at peanut farms, where harvested peanuts arrive at processing plants still inside their shells, mixed with bits of soil, stems, and plant material. Before anything else can happen, the peanuts must be cleaned. Conveyor-fed cleaning systems use vibrating screens, air classifiers, rotating drums, and magnets to remove sticks, dust, stones, and foreign objects. The goal is purity. Peanut butter factories accept only high-grade peanuts that meet strict moisture, size, and quality requirements. Once cleaned, peanuts travel to giant shelling machines. These machines crack the shells using controlled pressure and abrasion, peeling away the outer husk while trying to keep the peanut kernels intact. Air separators then blow shells away from the edible peanut, further refining the crop into clean, raw kernels ready for the next stage. The shelled peanuts still contain a thin, red, papery skin that must be removed. This skin is removed during blanching. Unlike blanching vegetables, peanut blanching involves either dry heat or steam. In dry blanching systems, peanuts pass through heated rotating drums that loosen the skins by thermal shock. In wet blanching systems, steam softens the skin before mechanical rollers wipe it off. After blanching, powerful suction systems pull away the detached skins, and optical sorters inspect the peanuts for color and quality. These optical systems use cameras and precision air jets to instantly reject peanuts that show mold, discoloration, or other defects, an important food safety step. With skins removed, the peanuts enter one of the most critical and flavor-building stages of all: roasting. Roasting not only gives peanut butter its signature warm, nutty aroma, but also drives off moisture, kills microbes, and prepares the peanuts for grinding. Most large factories use massive, continuous roasters, essentially long tunnel ovens where peanuts move slowly along conveyors through zones of gradually increasing heat. Temperatures often reach 160 to 180 degrees Celsius as hot forced air blasts across the peanuts. Sensors monitor airflow, peanut bed thickness, internal peanut temperature, and moisture levels. Over-roasted peanuts produce a burnt flavor. Under-roasted peanuts yield a bland paste. So this step demands absolute precision. As the peanuts exit the roaster, they are cooled immediately by forced air to halt further cooking. Many processors evaluate roast levels using electronic nose sensors or color analyzers, ensuring every batch hits the exact flavor profile designed by food scientists. After roasting, peanuts pass to post-roast inspection. Workers and automated sorting machines remove any remaining burnt pieces, foreign objects, or peanuts affected by aflatoxins, natural molds that must be carefully screened out. Approved peanuts travel onward to grinders, while rejected ones are recycled for non-food industrial uses. This ensures only the cleanest, highest quality nuts make it into peanut butter. Now comes the stage that transforms roasted peanuts into the smooth, creamy texture everyone recognizes: grinding. Industrial peanut butter grinding involves 2 or 3 stages of mechanical milling. First, roasted peanuts enter a primary grinder, often a hammer mill or coarse grinder, that breaks the peanuts into a thick paste. This paste is still grainy and warm. It then enters a second stage, the fine grinder. This machine uses spinning steel plates, stone mills, or high-speed colloid mills to shear the peanut particles down to tiny sizes, often just a few microns. The friction inside these mills generates heat, which helps liquefy the natural peanut oils, turning the mixture into a flowing, molten peanut butter base. During grinding, food scientists introduce stabilizers and additives depending on the type of peanut butter being made. Natural peanut butters receive nothing more than salt. Conventional peanut butters may receive tiny amounts of hydrogenated oils or palm oil to prevent separation. Emulsifiers help keep oil suspended evenly throughout the jar. Sugar or sweeteners may be added for flavored varieties, and cocoa, cinnamon, honey, or specialty ingredients may be blended for premium lines. These additions are metered with extreme precision. Too much stabilizer can ruin texture. Too little causes oil to pool at the top of finished jars. All additives must meet strict food safety and allergen requirements, and automated dosing systems feed them into the grinder at exact ratios. Once fully ground, peanut butter enters a temperature-controlled holding tank, a stainless steel vessel equipped with mixers that keep the mixture homogeneous while it cools. Peanut butter exiting the grinder can be as hot as 80 degrees Celsius. It needs to cool to around 50 to 60 degrees before packaging, so that the texture stabilizes and jars can be sealed properly. These tanks also act as buffer zones between grinding and filling, so the production line can run continuously, even as grinders undergo cleaning or adjustment. From here, the molten peanut butter flows through pipes toward the packaging area. All pipes are designed as sanitary food-grade stainless steel with smooth interiors that prevent residue buildup. Before entering the filling machine, peanut butter passes through filters to catch any remaining solid particles or contaminants. It then arrives at high-speed filling lines where dozens of nozzles dispense precise amounts into jars. These filling lines often use piston pumps or gravity-fed systems designed to handle thick, viscous food products. The fill weight is regulated down to fractions of a gram. Sensors check jar presence, alignment, and fill level. If a jar is underfilled or misaligned, it is automatically rejected. Immediately after filling, jars move to the capping station. Plastic or metal lids are applied by rotary cappers that spin lids onto jars in one fluid motion. A sealing band or tamper-evident ring is often heat shrunk around the lid to ensure consumer safety. Next, the jars pass through metal detectors and X-ray systems that verify no foreign materials accidentally entered during production. After that, the jars travel to labeling stations where high-speed labelers apply front, back, and nutritional labels. These labels must align perfectly at full line speed, and sensors confirm placement accuracy. Next, jars move onto packing conveyors where robotic arms or mechanical packers load them into cardboard cartons. These cartons are formed, glued, and filled automatically, then sealed and printed with batch codes, expiration dates, and production information for traceability. Full cartons then move to palletizing robots that stack them into stable pallets wrapped in stretch film. This protects the jars from dust, moisture, and shipping vibrations. Pallets are placed in climate-controlled storage areas until trucks arrive for distribution. Peanut butter production also requires extensive cleaning and sanitation. Every piece of equipment that contacts peanuts, grinders, tanks, pipes, nozzles, conveyors, must be cleaned using CIP systems that circulate hot water, alkaline cleaners, and sanitizing solutions. Because peanuts are allergenic, cross-contact controls are crucial. Factories have separate lines for peanut and non-peanut products, and allergen cleaning verification involves protein swab tests and optical inspection. Meanwhile, quality control labs inside the factory test every batch. Technicians measure viscosity, particle size, oil stability, flavor profile, moisture content, salt level, microbiological safety, and oxidation indicators. Peanut butter must be shelf-stable for months or even years, so stability testing is essential. Technicians place samples in accelerated aging chambers to simulate long-term storage. If the product separates, darkens, or changes flavor too quickly, the formulation is adjusted. Aflatoxin screening is also mandatory. Peanuts are one of the most carefully tested crops due to natural mold risks. Only lots meeting strict limits are approved. Lab technicians also perform sensory panels, tasting peanut butter for flavor consistency. From there, peanut butter enters the logistical chain. Pallets are loaded onto semi-trucks or shipping containers, equipped to maintain safe temperatures during transport. Distribution centers move the product through automated inventory systems, where it eventually arrives at supermarkets around the world. By the time a shopper twists open a jar and spreads the creamy or crunchy mixture onto bread, that jar has passed through dozens of mechanical, thermal, chemical, and safety checks, all invisibly ensuring quality, freshness, and safety. What makes peanut butter production so fascinating is the blend of traditional food preparation and modern industrial engineering. Roasting develops the aroma and flavor in a way humans have done for centuries, but everything afterward relies on precision machinery, automated controls, heat transfer science, microbiological testing, and ultra-clean manufacturing spaces. Grinding machines operate with tolerances measured in microns, filling lines engineer perfect thermal conditions, and quality labs monitor chemical markers to ensure shelf stability. And that is exactly how peanuts are cleaned, shelled, roasted, blanched, ground, stabilized, jarred, labeled, palletized, and shipped by the ton. A remarkable combination of food science, high-temperature roasting, mechanical grinding, packaging automation, and global distribution, ensuring that every jar of peanut butter tastes exactly the way consumers expect. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories and systems behind everyday products.